Case 1 where I'll be discussing the projection of a point in Co1. So let us say that the point we have is here and it is represented by a point A. Now we are going to look at this point from two different views. We are going to look at this point right from the front, that is, this is going to be your front view, which will be obtained in this VP, that is vertical plane, and at the same time we'll be looking at this same point from the top. So from this we are going to get a top view somewhere around this horizontal plane. Alright. Now the next thing that we'll be doing is I'm going to be telling you some notations. They are in the form of H and D. Now guys, please remember H is for distance, DIST, distance from HP, and D is for distance from VP. Alright, so the distance D is can be in front of the vertical plane and distance H is above this horizontal plane. Alright. Okay, so when you look at this point right from the front, you're gonna have a view, and that view in fact is going to be your front view. So it's gonna somewhere intersect this vertical plane over here. So this is going to be your front view, and I'll write over here simply A dash. A dash. Similarly, when you look at this object from the top, this projector is going to intersect this horizontal plane somewhere here, and this is what you call simply A. Now guys, this distance over here, you see this distance is what you call distance H, since it is lying above the horizontal plane, or the distance from horizontal plane. At the same time you have this distance, and this is what you call distance D, that is in front of the vertical plane. So always remember, and the next thing that I'll be doing is joining this front view with the top view with the help of this line over here. And you can clearly see so that since it's an orthographic view, that this angle is going to be obviously 90 degrees. But now our objective is to convert this pictorial representation. This is what you call, guys, a pictorial representation, and we are going to convert this pictorial representation into an orthographic view. And for doing so, please watch the steps carefully. We are going to rotate this horizontal plane by an angle of 90 degree clockwise, CW clockwise, and on doing so we'll have this vertical plane as well as horizontal plane coplanar, so that it can be drawn on a drawing sheet or a plain sheet of paper. Alright, so initially I'll be starting off with this guy, that is this line. This is what you call a reference line XY, and let us draw this reference line. Okay, now above this reference line we have this VP, and below this reference line we have this HP. So this is X, this is Y. As far as point A dash is concerned, it's going to be somewhere here. This distance is obviously going to be H, and we have this projector line, and somewhere down here from this distance we have point D. Always remember, guys, that you need to put a dash with H. So the name of the point is A, so you need to put a dash with A. Alright, since this dimension is H, and with D you don't need to put a dash, it's simply A. Okay guys, so that was all about first quadrant. Now we're going to be dealing with case 2, that is point in second quadrant. So in this case we have a point which lies behind the vertical plane and above the horizontal plane. So this is what you call simply point A. Let us say the name of the point is A, and we are going to draw its projections, and for that we need to have a view. Now we are going to look at this object, that is in fact a point, from the front, and the same object we are going to look at it from the top. Now guys, the problem is when you try to look at this object from the front, it appears as if between the observer, this is what you call the observer, and this is point A, that is in fact an object. So between observer and object you have this plane of projection. Okay, so this is what you call plane of projection. So this acts as a hindrance. So what happens when you try to look at this object up from here, you will have this plane of projection in between. You cannot see this object. So in order to make sure that you can see the object, you need to make this plane of projection transparent. So this is basically a case which happens in quadrant number 2, and as far as first quadrant was concerned, there was no requirement to make any plane of projection to be transparent. Okay, so now let us look at this object right from the front, and when you look at it, this is the transparent plane, vertical plane. You are going to end up having its front view somewhere around here, and this, guys, is what you call A dash, since it's a front view, A dash. All right, now we are going to look at this object from above, from the top, and it's going to cut this horizontal plane somewhere here, and this point is what you call simply A. All right, so let's write over here A. Few of the dimensions which are to be done. This is the line which connects both the views, that is front view as well as top view. This over here is what you call the front view, this over here is what you call the top view. One more thing that I would like to elucidate is this distance. This distance is in fact behind the vertical plane, and any distance associated with vertical plane shall be represented by d, and this distance over here, you guys can see this distance is above the horizontal plane, so it has to be represented by h. Alright, now we are supposed to draw an orthographic view for this pictorial representation. How that can be done? Please have a careful look. Again, the same policy. In the previous case also I told you that the horizontal plane has to be rotated by an angle of 90 degree clockwise. The same thing will be done and repeated in this case also. So what we're going to do is we'll rotate this horizontal plane by an angle of 90 degrees in the clockwise sense. On doing so, what will happen? This vertical plane and this horizontal plane, both of them are going to overlap. All right, something like this. All right, this horizontal plane is going to be overlapping with this vertical plane above this so-called XY line. So you're going to end up having something like this. This is what you call the XY line, the very popular XY line, X and Y. All right, and already the vertical plane is already lying above this XY line, and since horizontal plane comes and patches up, overlaps with the vertical plane, so we are going to have a horizontal plane also with this vertical plane. So both of them are overlapping. You can also say that front views and top views are going to mix up, so it's going to be very difficult for you to figure out as to which part of this is the front view and which part of this is the top view. That's why all over the world you're going to see people advising or going for first quadrant projection or third quadrant projection. In India, Russia, and I guess in the UK, they follow the projection of point in the first quadrant, or assuming the object above the HP and in front of the VP. Whereas when you go to countries like the USA and some other North American and South American countries, they follow the third angle projection, where the object is assumed to be below the horizontal plane and behind the vertical plane. So I'll be taking up that case also, but before that, let us finish this second quadrant. So when you do so, we'll have this vertical plane and horizontal plane, both of them lying above this XY line, and this is going to be the projector line, guys. Now these two lines are also going to overlap each other, since this is going to make a 90 degree angle and then rotated and overlapped. Okay, so this is where we are going to find point A dash. All right, and this is going to come over here, and A, that's A. This, guys, is what you call H. All right, see this, and this over here D is going to lie somewhere here. So that's point D for you. So that's all, guys. This is what you call front view, this is what you call top view. Always put a dash with this dimension H, no dash with this dimension D. So that was all from my side. Always remember, in second quadrant you don't get to see the point from the front, and hence you have to make it this vertical plane transparent. That's it, guys. So now let's head over to case number 3. It's going to be real fun, guys. So guys, this over here is quadrant number 3, and you can clearly see that the point, I'm going to put a point over here, this point is below the horizontal plane and behind this vertical plane. Okay, now we'll try to find its views. Obviously the front view is going to lie on the vertical plane, and we're also going to have its top view obviously on a horizontal plane. Now let us say that the name of this point is A, and when you try to look at this object right from the front, what happens, this vertical plane comes in between, so you won't be able to see this object. Okay, and at the same time, when you try to look at this object from the top, this horizontal plane comes in between. So in order to visualize the object, that is in fact a point, you need to make sure that these two planes are absolutely transparent. So one thing that has to be done is to make both the planes transparent, both HP and VP. So both of them are to be made transparent, and then when you do so, you can easily have its views. So the front view is going to lie somewhere here, so this is going to be the intersection point, and I'm going to write over here A dash. Okay, so let's have this line done. Now when you simply look at this object right from the top, you're going to have the intersection point over here. Okay, and this is, guys, is what you call the top view. So this is represented by simply by A, and again let us connect this front view with this top view. Now what about H, what about D? Let us have those distances worked out. Now I've already told you any distance below or above the horizontal plane is represented by H. So this over here, guys, is what you call distance H. Okay, and here we have this distance that is in fact behind the vertical plane. So this is what you call the, okay, now again the same philosophy. We know that horizontal plane has to be rotated by an angle of 90 degree in the clockwise sense. All right, and when you do so, you'll have this xy line. So let us make this corresponding orthographic view. We have this in front of us an xy line, okay, and this distance will be above, all right, something like this, all right, and this point over here is what you call point A dash, and this distance, you can work out this distance. What is this? This is the, all right, now this distance, we are worried about this distance over here, and below this distance we are going to have yourselves point A dash, that is in fact the front view. Okay, so make this correction, guys, this is not A dash, this is simply A. All right, so let us go down below, and over here we are going to have ourselves A dash, and this dimension, you already know that wherever there is a dash there has to be an H, and vice versa. Okay, so this is what you call the front view. Front view is below the HP XY, so front view is below XY line and top view is above the XY line. All right, so it is exactly, this particular projection case is exactly opposite to the first quadrant, where the front view was above XY and top view was below. Here the top view is above XY, front view is below, and over there in the first quadrant we have this X above XY line, we had vertical plane, and below XY line we had horizontal plane. But as far as third quadrant is concerned, you're going to have this XY line, above which you will have this horizontal plane, in which you have this top view. All right, all of them are connected to each other, no dash, and below this XY line you will be having a vertical plane. All right, guys, so this is what you call a vertical plane, in which you will have this front view, and front view is accompanied with a dash. So that was all in quadrant number 3, and now let's head on to quadrant number 4 for our final case. So now let's focus in this fourth quadrant, and we have a point over here, and you can clearly see that this point lies below this horizontal plane and in front of the vertical plane. Okay, so let us say that the name of this point is again represented by A, and now similarly we're going to look at this point right from the front this way for the front view, which is going to be obtained somewhere here in this vertical plane. Same time we're going to look at this object right from the top for the top view, which is going to be obtained somewhere around here, that is the horizontal plane. Now guys, the problem is when you try to look at this object from the top, this horizontal plane tends to come in between. Okay, and for that reason HP has to be made transparent. All right, fine. Now let us see, when you look at this object from the top, this is where we're going to have the top view. So this is the top view of the point, and let us say that this top view is represented by simply writing A. Okay, same time when you look at this object right from the front, no issues, this is the observer, this is the object, and behind it is the plane of projection, which in fact in this case is a vertical plane. So this is going to be the front view. You need to put a dash with this front view. Okay, now let us join this front view with this, what you call, top view. Let us do so, and obviously this angle is going to be 90 degrees since it is an orthographic projection. Now both the principal planes are at 90 degree angles, right angles. All right, now the next thing to be done, same old story. What you do, you need to rotate this horizontal plane by a certain angle. You know that certain angle, 90 degree clockwise. Okay, so you have this XY line, and what will happen when you, after you rotate this horizontal plane by an angle of 90 degrees, this vertical plane and this horizontal plane are going to overlap. All right, and what will happen, this, it's going to get difficult for us to figure out as to which one is the front view, which one is the top view. This is the point, this can be figured out, but when you speak of real front views and top views of complex machinery, or say even the plan and elevation of residential buildings, it's going to get really difficult to figure out which one of which part of this is the front view and which part is the top view. That's why it is not advisable to draw or to prepare drawing assuming the object to be below HP and in front of VP. Okay, it is always advisable to make sure that the drawings are done in first angle or third angle, that is in the first quadrant or in the third quadrant. All right, now let's focus our attention towards drawing its corresponding orthographic view. So we have this XY line, okay, and below this XY line we have this vertical plane, and after rotating this horizontal plane, this HP overlaps with this VP. All right, so I'm going to write over here HP. That means it's clearly means that the front view as well as top view, both of them are going to lie below this XY line. All right. Always remember, guys, you need to put a dash. Okay, so this distance is in front of the VP, so this is represented by D. This distance over here is below the HP, has to be represented by H. We all have used this notation before in the three cases. Now the next thing to do is assuming H is greater than D. Okay, so we'll have this H is greater than this D, A dash, and this over here is going to be the corresponding dimension H. Let us say D comes out here, so this is going to be dimension D, and that's no dash, simply A. So this is how you need to draw the projection of any point in fourth quadrant. This represents the front view and this A represents the top view. Both VP and HP are lying below XY line.